Hello, everyone. In today's video that I'm making for y'all, we're going to review quadratic expressions and equations, right? Especially when in regards as we move into quadratic functions, we want to make sure to review some of the necessary skills that we have to work with. So here below, I have four functions that we're going to look at. And for the following functions, we want to identify all the intercepts that they have. This first function here, right? We want to remember that the two intercepts we're going to try to find are going to be our y-intercept, and we're going to plug in 0 for x, and then our x-intercept or intercepts, because we're probably going to have two since we're working with a quadratic. With that said, this is where the 0 comes in. For y-intercepts, again, we plug in 0 for our x value. For x-intercepts, we plug in 0 for the y value. All right, so let's start off with finding our our y-intercept. And we're going to say, hey, our function f, when we plug in 0, we'll get 0 squared minus 5 times 0 minus 14. With that said, though, wherever you see an x and you plug in 0, it's going to be 0. So we're only going to be left with our constant term. So we find that our y-intercept is actually going to be the point 0, negative 14. And that's going to be something we want to make sure to keep an eye on as we work through this. Whenever we find a y-intercept, if we have a polynomial, not just quadratics, the constant term will help us know what our y-intercept is for the y value. The next step then is to find the x-intercepts. When we set this equation equal to 0, though, we have an equation that we now need to use factoring to solve. If you recall, the zero factor property says that if I have two things multiplied together, in this case A and B, and they equal 0, then one of those factors has to be 0. It doesn't matter which one, but one of them has to be 0. So that's what we want to use here. All right. Now, factoring by grouping is the way that I like to show this. So just as a quick reminder, if I set this up as x squared minus 5x minus 14, we could build a quick little t-chart where we use a times c and our b value, where a is 1, b is negative 5, c is negative 14. And we want something that multiplies to a times c and adds to b. So my a times c here is going to be negative 14, and our b value is negative 5. So the best approach here is to look at factors of 14. So for factors of 14, we have 1 and 14, and then 2 and 7. And what we like to see here is if we just did a quick subtraction, 2 minus 7 does equal negative 5. So we can say, hey, negative 7 times 2 gives us negative 14. Negative 7 plus 2 gives us negative 5. That allows us to move forward with our factoring. The factoring by grouping method says that, hey, if I replace my negative 5x with negative 7x plus 2x, I can use GCFs to factor this. So the first two here share an x in common. So we could write that as x times x minus 7. And then the second two here share a 2 in common. I'm going to write that as plus 2 times x minus 7. Now, what we like to see here is the fact that both of these groups gave us the same factor in the parentheses. Both of them was x minus 7. So that means we can actually go one more step in our factoring and write this as x minus 7 times x plus 2. And also now we have the factors of this quadratic. Now, make sure you know I showed factoring by grouping, but if you have another way you're comfortable with factoring, that's perfectly fine. But we needed to get to that point of multiplication. We want this multiplication here so we can take our factors and set them up to equal 0. But with the factoring done, let's move forward into that process where we say, hey, now we can say x minus 7 equals to 0 or x plus 2 equals to 0. In solving these linear equations, we find that we do indeed get two different solutions. Now, make sure you remember, though, our objective here was to find x-intercepts. So we have 7, 0 and negative 2, 0. So we found one y-intercept, which as a function, we should only have one y-intercept. For each x, there's only one y. And then for our x-intercepts, we found two different solutions. Now it's okay here, it just means the function is not one-to-one. Still a function, just not one-to-one. Now that's one perspective of factoring that we usually do whenever we have what we call a trinomial with three terms. The next problem I had set up is what happens when we have two terms. Okay. Well, hopefully you see here, we can start by finding the y-intercept, but when I plug that in, I don't have a constant term. So my y-intercept here is just going to be 0. All right. So 0, 0 is going to be my y-intercept. So moving forward into our x-intercepts then, we will take our function again and set it equal to 0. Now, one thing you should always look for in factoring is what we call a greatest common factor. I didn't use one on the previous problem, but here we do have one. And we note this by the fact that both of these have an x, right? On top of that, though, 3 and 6 share a common factor of 3. So we can factor that 3x out by writing this as negative 3x and then set up distribution. Now make sure you see the x squared was negative, so I brought the negative out with it. That just means as you do your division, make sure you note, like, hey, negative 3 divided by negative 3 is positive 1. But we would also have an x left over as well. 6 divided by negative 3 is negative 2. And I don't need the x there anymore. And if you need to write that out, make sure you do that. That's what is going to help you in doing the division. Now, at that point, we have our factors. We can then take our factors and set them equal to 0. And then we can solve here. Now, make sure you see with this problem, we could divide both sides by negative 3, and we get the 0 again. And then over here, we get positive 2. Now, we should not be surprised by this one here because we already stated that that was true. We should expect to get the 0. All right, because the origin is a y-intercept and an x-intercept. So when you write that down, know that that should be duplicated. But that would be a perspective where, like I said, this first one was a trinomial. So go through the methods that you like to factorize. You factor them by grouping. The second one was a binomial. It only had two terms. And the focus is always make sure you check for greatest common factors. This third one, again, is a binomial. All right, so when we look at h of x here, it's a binomial again that we can go through the process of dealing with this, right? So make sure you see here, though, for our y-intercept, when we plug in 0, we'll get 9. But 0 squared is 0, which would leave us with a 9. This binomial, however, is different because when I go to deal with the x-intercepts, I have a special factoring process that I can work on. Okay, and this is one of the ones that you want to make sure you have by memory. We're going to need it in different situations. Move forward with polynomial functions as well as you deal with stuff like rational functions. But make sure you see here, this is a difference of squares. So I write this as 3 and x into two factors, right? Because we have x squared, we're looking for two factors. And then we need to alternate our signs, called the difference of squares. Make sure you see here, 3 times 3 gives us the 9. X times x gives us the x squared. But it is a negative x squared, which is why we need the alternating of signs. Now, with that in place, we can again set these both equal to 0. And we'll get 3 equal to x when I add the x to both sides. And then x equal to negative 3. So once again, we found two x-intercepts. And I'm writing them wrong. Be careful. The x goes first. Now, some of you might also look at this and say you can solve it another way. So just to make sure I show that, you can use the square root property to solve. If you choose to do that, though, make sure you remember the proper way to do so. So if you choose to get the x squared by itself and use a square root to solve, you must remember that the square root property tells us that I have two solutions, the plus and the minus, right? The positive and the negative of whatever the square root is, which the square root of 9 is 3. And make sure you see that that still is agreement with what we found already. Now, with that said, though, this was definitely a focus on factoring again, but there's going to be times where we have to do a square root. So let's keep that in mind as well. And that's where this last problem comes in. As we deal with quadratics, not everything is going to be factorable. So we have to be prepared to what to do when we can. All right. Now, first, just make sure you see here, I'm going to write it up to the top so we have room, that our y-intercept is going to be at 0, 29. All right. As we go through there, those x terms will go to 0, and we'll be left with 29. Now, when we go to deal with our x-intercept, we're going to run into a situation where factoring will not work. If you try to do that little t-chart like I showed before, we'll find that a times c gives us 29, and our b value is 10. And the only factors of 29 are 1 and 29. So there's no way for me to build 10 from 1 and 29. So I will not be able to factor. This is where we would say, like, oh, the trinomial I'm working with is prime. I can't do it. So we have to have another way. Now, we can jump straight to the quadratic formula. However, we need to make sure we review completing the square as well. All right. So since we can't factor, completing the square is a method to force the trinomial to factor. All right. So what we're going to say is let's get rid of the term that doesn't have a variable on it, so that all the x's are on one side and my constant term is now on the other side. The next step is to ensure that a is 1, which, as you can see here, a is already 1, so I got that. So I got my x's isolated, a is 1. Now we can move into completing the square. Now, just as a reminder, completing the square is saying that we want to get something that looks like, say, x plus r squared, where those two factors are identical. We don't just want to have any factors. We want two factors that are completely the same. That's why we call it completing the square. With that said, when we multiply this out, we're going to get something that looks like this, where the thing that we're missing is the r squared. That's all we need to find. What do I put for r squared? Well, the good news is we have a way to get to it. But make sure you see that that's 2r. So this 10 here represents 2r. So to find what we're working with, what we're going to say is our new c value, we're going to say take half of b and square it. And remember, the reason we're taking half of b, because when we do this multiplication, we get two of them, not just one of them. And the reason we're squaring it is because we want it to be squared. Now, the whole point of doing this is to have two factors that are completely the same. So when we go through this process, we'll have 10 divided by 2 squared, which is 5 squared, which is 25. I now have the number I need to use here, where we could say, hey, let's just add a 25 to both sides. Now, what you're going to find is this will allow us to force us to factor to x plus 5 times x plus 5. On the other side, we're now going to have a negative 4. Now, the reason we like this is because we can go back to that method we just talked about, the square root property. I can write x plus 5 as x plus 5 squared. Those two factors are the same. With that, we can now take a square root to solve. But make sure you keep in mind, though, the whole point we call it completing the square was to get to this point. Because once we get here, hey, I can conveniently use a square root to solve. That'll give us just x plus 5 over here. But make sure you remember that'll be plus or minus the square root of negative 4. Now, with that in place, we can write this as x plus 5 equal to plus or minus 2i. and then subtract the 5 from both sides, and we have our two solutions. Now, the key here you have to be careful of is make sure you note that this was a -4 and we now have an I involved. So when I ask you to find intercepts, we do not want complex numbers. So what we would conclude here is that we have no x-intercepts. That means this graph will never cross the x-axis. All right. Now, to make sure I show it though, as I mentioned, when you're dealing with x-intercepts, you could have used the quadratic formula. So we could set our function equal to 0. And then remember, we still need to be able to identify A, B, and C. But setting up the quadratic formula, we would have x equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we would have -10 plus or minus the square root of 10 squared minus 4 times 1 times 29 all over 2 times 1. So this will give us again -10 plus or minus the square root. So that's going to have 100 minus it's what, 116? Okay. Which would then give us -16 in our square root. Now, at this point, if you're paying attention, you can go in and say, hey, this is going to be complex. So you could just say, hey, not real, no x-intercepts. But know that you could go through and simplify this more by saying -10 plus or minus 4i all over 2. And then separating the 2 to both parts. -10 divided by 2 gives us -5. And then the 4 divided by 2 gives us 2i. So it's the same thing we found before. But make sure to note that when you're using the quadratic formula, if you get a negative under the square root, you don't need to proceed any further. You could just say, hey, that's not going to be real. We won't have any x-intercepts because that was our objective here. Now, as always, if you have any further questions or concerns with the material, please make sure you get in touch with me. Have a wonderful day.